Now, what about central of symmetry? If A is minus 1, yani z prime equal minus z plus b, we can write it as ei pi z plus b. This is a rotation, but rotation of angle pi. So m will be m prime. So here we say it's central of symmetry, and the center will be zw will be b over 1 minus minus 1, 1 minus a, so it will be b over 2. In that case, wm equal wm prime, and vector gamma m equal minus gamma m prime. Here we put vector because the points are collinear. But if b is 0, so the central of symmetry will be has center origin, or 0, 0. This is not related to rotation, but this is included in rotation. Symmetry with respect to a straight line. Always, we have a straight line, a line of symmetry. If you have z prime equal a z bar plus b, but be careful, norm of a must be 1. If you have this case here, we have line is a system of symmetry, set of symmetry points, which is a line. So here, if you want to prove it, we need to prove that this line is a double point. We're going to find it first of all, and then we're going to prove that the slope of m prime and d equal minus 1, the product, to be perpendicular. And if I is the midpoint of m prime, this I must be belong to the point D. Let us take an example. Suppose you have this one. If you want to do norm here, you're going to get root 9 plus 16, which is 5. 5 over 5 is 1. You have z bar. Khalas, this is a central symmetry. So what do? Since a norm of a is 1, so we equate z prime equal 1 over 5 minus 3 minus 4i. Z bar is x minus iy. So we put here x minus iy, and we multiply all of these. We're going to get, this is the real part and this is the imaginary part. So this will be x prime and this will be y prime, as you can see. To be a double point, the line, so we equate x prime to x. So we say suppose x prime equal x and y prime, to find the set of double point, and y prime equal to y. So if you do it here, as you can see, you're going to get in up and down the same line. You must have the same line. So this is the central, the symmetry line of the transformation z prime equal a z bar plus b. Now we want to check that the slope of the line and that of m prime is minus 1. So we're going to do the slope of m prime. So slope of m prime is y of m prime minus y of m. This is y of m prime, this whole one here, minus y of m, which is y, over x m prime. This is it, minus x. If you do the calculation, you're going to get half. Half times minus 2 is minus 1, so correct. And now we pick the midpoint of m prime. It means x prime, this is x prime, plus x over 2, y prime plus y over 2. You have this point. You need to check that this point is on the line. So you replace here minus 2x plus 3x by this whole expression, as you can see here, plus 3. You're going to get y of the point. Check it by yourself. Summary of what we covered. Suppose z prime equal az plus b. If a is 1, so it's a translation. If you have z prime equal ei alpha z plus b, we have a rotation where zw is b over 1 minus ei alpha. Hala, if a is minus 1, you have central symmetry of center b over 2, as we said. And if z prime equal minus z, so here the center will be the origin. If z prime equal az bar plus b, where norm of a is 1, we have symmetry with respect to a straight line D. Hala, if z prime equal z bar, suppose here you have z, and z prime equal z bar, so here it's symmetric with respect to the x-axis, and if it's equal minus z bar, symmetric, it will be here z prime equal minus z bar, so symmetric with respect to the y-axis. Now suppose we have a rotation of center W angle alpha that will take A to A prime and B to B prime. We need to show that the rotation of the line AB will be A prime B prime, such that AB equal A prime B prime and the angle between AB and A prime B prime equal to alpha. Since R of A equal A prime, so Z A prime equal EI alpha Z A plus B, RB prime RB equal B prime, so Z B prime equal EI alpha Z B plus B. So To prove this one, we're going to do the ratio zb prime minus za prime over zb minus za. So this is zb prime, we write it, minus this is za a prime. So you can b plus b minus b cancel out. You can put ei alpha in factor. You have this common, which is equal ei alpha. So it means that angle AB a prime b prime is alpha, and the line AB and a prime b prime are equal. Okay, this is a proof. And we check that in GeoGebra, the rotation of a circle is another circle with same radius, but the center b prime is the image of b by rotation w alpha. We're going to start by application problem. Determine nature and characteristic elements of the given transformation. If you look at this first one, this is a translation because coefficient of z is 1. Translation of vector 3i minus 2. Here this is ei pi over 4 pi over 3z. So this is a rotation of center 0, because plus b, I don't have b, it's 0, and angle 4 pi over 3. Don't forget the norm here must be 1. If it's not 1, it's not a rotation. Here, if you do the norm, it's radical 1 plus 1 here, 2 times radical 2, 2 over 2 is 1, and this angle is minus pi over 4. Now if we want to find the center, so it's a rotation of angle minus pi over 4 and center zw, 2 minus I over 1 minus this whole expression. You can use your calculator and get the answer here. Number 2, given a rotation r of center w3 minus 1 and angle minus pi over 2, write it. So z prime equal e minus I pi over 2, which is minus iz plus b. But what is b? This is the center. So b is one zw into 1 minus a. So this is zw, 3 minus 1, 3 minus I. Times 1 minus a, 1 minus minus 1, so it's 1 plus 1. So this is the complex expression. I want to write it in analytical form, so you need to say x prime plus iy prime equal minus I into x plus iy plus 4 plus 2i. You equate real to real and imaginary to imaginary. Part C. Given this one, find the set of point mz. So here we put 2 in factor. We take it to the other side equal to 4. So z belongs to the circle of center 4 minus 1. Minus 1 and 4, and radius equal to 4. You can do it this way, or you can put here x plus iy minus 4i plus 1. Do the norm. You're going to get the same thing. D2, let Rm equal m prime. Find the set of m of points m prime. Okay, so here before we have m, z belong to circle, m yani belong to circle of center minus 1, 4 and r equal to 4. So the rotation of a circle is a circle, so you must have the same radius, which is 4. Now I want to find the image of minus 1, 4. I have from before z prime in part a minus iz plus 4 plus 2i. So I replace z by the center minus 1 plus 4i. So you have the new center. So m prime will belong to a circle of center I prime 8, 3 and radius equal to 4. Or if you want, we can start by norm of z minus 4i plus 1 equal to 4. So x plus iy minus 4i plus 1 equal to 4. And remember in part B we did this, we wrote it in analytical expression form. So the x here will be 2 minus y prime, and the y is x prime minus 4. So if you do you put the real with the real like here, and the imaginary with the imaginary, and you do it, you're going to get z prime minus 3i minus 8 equal to 4. So m prime belongs to a circle of center 8, 3 and radius equal to 4. So the first method is easier. It's direct to find directly the center, since we know that the radius is the same.